All right, so this is going to be objective 8. We are going to add, subtract, multiply, divide, and continue to simplify radical expressions. Okay, we simplified basic radical expressions yesterday. There is a little more to it. We're going to talk about rationalizing a denominator today. Anybody heard of rationalizing a denominator? You may not know what it is, but you've heard of it. So rationalizing a denominator means you get a denominator out of the, you get a radical out of the denominator. You cannot have a radical in the denominator. It's just not proper, okay? So all of our answers, you have to rationalize your denominator. I will tell you, you need to get good at rationalizing your denominator because you will rationalize in trig, you will rationalize in pre-calc, you will rationalize in calculus. So rationalizing is a skill that you definitely will need to know, okay? All right, so let's go to example 1. The square root of x to the 6th divided by y to the 7th. So I'm going to kind of give you a little preview of rationalizing. And then I'll give you the definitions and we'll get into it a little bit more. So here's a little bit of a preview. So when we are dividing, first of all, is the root or the radical, is it in the numerator, is it in the denominator, or is it in both? It's in both. Sometimes you only see it in the numerator, sometimes you only see it in the denominator, sometimes you see it in both written separately, and sometimes you see it where everything is underneath the radical. So the first thing that I would do, is I would separate it. So this is going to be the square root of x to the 6th divided by the square root of y to the 7th. What do you think we will do from there? Simplify. Yeah. How about the square root of x to the 6th? Is it perfect? Yes. So it can come to the outside and become what? X to the 3rd. So when dividing radicals, you'll separate them and then you'll simplify them. Y to the 7th, is it perfect? No. What's the highest multiple 2 that can go into 7? 6. So this is going to become y to the 6th times y. And you can take this guy out. So x to the 3rd over y to the 3rd times the square root of y. Any questions so far? Now, here's where we get into, just a minute ago, we talked about rationalizing. Here's your little preview of what rationalizing is. We cannot leave my answer like that. We cannot leave that square root in the denominator. Okay, we've got to rationalize it. We've got to get rid of it. So normally to get rid of something or cancel something out, we do the opposite. Very good. Okay, we do the opposite. So normally if I add 2 to get rid of it, I will subtract 2. Okay, if I'm timesing by 2 to get rid of it, I will divide by 2. So if I want to get rid of the square root of y, what's the opposite of taking the square root? Squaring it. Yeah, squaring and taking the square root are opposites of each other. So what does it mean to square? Multiply it by itself. So we're going to do the opposite and we're going to multiply by itself. Everybody agree? I have just squared the square root of y. Okay? So normally when you multiply, you can multiply what's on the outside of the radicals, outside with outside, and then you can multiply what's on the inside of the radicals, inside with inside. So here, I can multiply inside with inside. So the square root of y times the square root of y is the square root of y squared. What do we know about the square root of y squared? Is it perfect? What's it equal to? Y. It's just y, because you divide it by the root and it becomes a 1. Okay? It's just y. So have we achieved our goal? Have we gotten rid of the square root? Now, I will tell you, earlier today, someone thought that these just cancel. They don't just cancel. We are canceling out the radical. What's underneath will still be left. Does everybody understand that? What's underneath will still be left. So, let's take a look at what we have. So to get rid of this radical, we just learned that we are going to square it, which means we're going to multiply it by itself. So I'm going to multiply it by the square root of y. And if I multiply by the square root of y in the denominator, then I must multiply by the square root of y in the numerator. Okay, so here we go. On top, outside with outside, inside with inside. Well, the x cube's on the outside, the y is on the inside. How do I times them together? You can't, so what do I do with it? Smush them. So I will have x cubed times the square root of y. Everybody understand that? On the bottom, technically there's a 1 on the outside of that radical. So outside with outside, y cubed times 1 is y cubed. And we just learned that the square root of y times the square root of y is y. It just leaves you with the number under the radical. Technically, it's the square root of y squared, but we know that this is perfect, and when it comes to the outside, it becomes a y. So up top, I have an x cubed times the square root of y. In the bottom, what will I have? A y to the fourth. Now, if you can simplify things, outside with outside, inside with inside, you should. And occasionally, you might have problems that things can go further, always looking to see if it's fully simplified. But my question is, can I simplify this y under the radical with this y, one of the y's to the fourth? No, why not? Because one's on the inside and one's on the outside. So what if I had like a x squared here? Could I simplify the x cubed with the x squared? Yes, because they are both on the outside. But in this case, nothing matches, so I can't. Okay, any questions on rationalizing the denominator? So there's your preview. There's your definition. To rationalize the denominator is the process of eliminating a radical from the denominator. Everybody got it? Process of eliminating a radical from the denominator. So I have the square root of a to the ninth over b to the fifth. So what would be the first thing that we should do with this? Separate it. Okay, where is the radical? The radical is in the numerator and in the denominator. And again, sometimes it'll only be in one or the other. Sometimes if it's over the whole thing, you need to realize that it goes to both. So let's see if we can simplify this. A to the ninth, is it perfect? No. So what should it break down into? A to the eighth times A. How about B to the fifth? B to the fourth times B. Very good. All right. So A to the eighth is perfect. It comes to the outside as A to the fourth. Very good. Times the square root of A. And B to the fourth is perfect. It comes to the outside as B squared times the square root of B. Can I start to simplify anything? Anything on the outside match? Anything on the inside match? If you could, you would, but we can't, so we won't. Okay? So am I finished? No, what's my problem? What's my issue? There's a square root in the denominator. Is the square root of A okay? It is A-okay. Okay? It is just fine. So, but you cannot have the square root of B in the denominator. So how would I get rid of the square root of B in the denominator? The opposite of taking the square root is squaring. So if I square the square root of b, that just means I'm going to multiply it by itself. So I'm going to times by the square root of b in the denominator and the numerator. Okay? So up top, outside times outside, inside times inside. So what will I have? A to the 4th times the square root of AB. Very good. Divided by, on the outside here, b squared times 1 is b squared. What's the square root of b times square root of b? It's the square root of b squared, which is technically just b. Just a b, right? And so all together, I have a to the 4th square root of ab divided by b cubed. Can I simplify my b's? Why not? One's on the inside, one's on the outside. So I'm finished. Okay. Right. There's no, because technically it becomes the square root of b squared. But what is that? When you take it to the outside, it's just b. It's just b by itself. Does that make sense? Really quickly, let me just do a little skill with you. Okay, you don't need to write this down, but really quickly, what's the square root of 5 times the square root of 5? Square root of 25, which is just 5. It just leaves you just the number under the radical. I like to say this. Another way to write this would be square root of 5 squared, and here's my jam. What do we know about a square and a square root? They're opposite from each other, so what happens? They cancel. They cancel each other out. What are you left with? Just a 5. Does that make sense? So what's the square root of 7 times the square root of 7? 7. Technically, it's the square root of 49, but square root of 49 is just 7. What's the square root of AB times the square root of AB? AB. Technically, it's the square root of a squared b squared, but that is just AB. Does that make sense? It just leaves you the number under the radical without a radical. Okay, question. Like this. And then I'm going to square it too. Like that. Would that be okay? Okay. So technically, you would do outside times outside. So 3 times 3 is 9. Okay. And square root of AB times square root of AB is just AB. So it would be 9AB. You multiply the outsides and get 9. And then when you do square root of AB times square root of AB, you just get AB. Okay. We'll do more. We'll do more. Okay. But that's a good question. All right. So you try this one on your own. What do we think about the answer? Y to the 4th times the square root of x divided by x squared. Do we agree or disagree? How many agree? All right. All right, so let's see. If you didn't get it, let's see where we went wrong. So, y to the 8th is perfect. It can come out as a y to the 4th. Square root of x cubed needs to break down into x squared times x. But x squared can come out as a what? As an x times the square root of x. We're not finished because we need to, what's that word called? We need to rationalize the denominator. So we need to times by the square root of x on the top and the bottom. What does that equal? What's the square root of x over the square root of x? 1. So it's okay to do that because it isn't changing my problem. Because I'm timesing it by 1. That's a 1 right there, right? All that's equal to 1. So that's why you're able to do it, okay? And that's why if you times by it in the bottom, you got to times by it in the top as well. So these just smush together. Y to the 4th times the square root of x. On the outside here, x times 1 is just x. What's the square root of x times the square root of x? X. Another x. And so how many do we have? 2. And so my question is, can you simplify those? No, because one's on the outside, one's on the inside. All right. Are we okay with division? You just covered division. Yes, are you okay with rationalizing the denominator? All right, so let's move on into multiplication. We've already discussed this a little bit today. How do you think we will multiply? Outside times outside, inside times inside, and then simplify. Very good. So, all right, so outside times outside is 15 times the cube root, negative 12 times 18. Negative 216. A times a squared. A to the third. B to the fourth times b squared. B to the sixth. Okay. And then we're just going to simplify. Now, here's the thing. Yesterday, we talked about that you couldn't have a negative under the radical yet because we have not learned complex numbers. Okay, it's going to come out to be imaginary. Did we say you couldn't have a negative under all radicals? Just the even ones, right? This is an odd radical. So it's okay to have a negative under an odd radical. Can you multiply something 3 times? Cube it. You follow me? A negative times a negative is what? A positive, and a positive times a negative is a... And so you can do a negative times a negative times a negative and get a negative under the radical. And that is okay. So tell me, using your calculators, what is the cube root of negative 216? Negative 6. So I will tell you on problems on your homework, you can just bring the negative on the outside with it. Okay, that was a question that we had in second block. So as you have negatives, and today they'll be under odd radicals. They won't be under any even radicals. They'll be under odd radicals. So what do you do with the negative 6 and the 15? And you get negative 90. Is a cubed perfect? Yes. It comes out as a. Is b to the 6th perfect? It comes out as b squared. And so, and again, when you don't have anything under the radical, you don't have to write the radical. Technically, there's a 1, but cube root of 1 is just 1, and anything times 1 is itself. So you don't have to write the radical. Okay, any questions on that? Multiplication pretty easy? All right, good. So you try that one. Moving right along. Okay. So outside times outside, inside times inside. 2 times 3 is 6 times the cube root of 16, x to the 8th, y to the 4th, and then we need to try to simplify. Is 16 a perfect cube? No. So we need to take it and break it down. This becomes 2 and 2. So how many groups of 3 can I circle? 1 set of 3. So that's how many 2's that are going out. This comes out as 1 set of 2's. So what will I have on the outside? 12. And then on the inside, I'm going to have that guy by himself times the cube root of 2. X to the 8th needs to break down into x to the 6th times x squared, right? Highest multiple of 3 is 6. And then y to the 4th needs to break down into y to the 3rd and y. So we can take these 2 to the outside. So this will become 12x to the 2nd y times the cube root of 2x squared y. How many got it? If you didn't, do you know where you went wrong? Right, okay? All right, so we're going to try one more, and that will take us to lunch, I believe. All right, so here we go. Example 6. 6 times 4 is 24. And then times the square root of 16, c to the 4th, d to the 8th, all of which are perfect, right? So 16 comes out as a 4, and when you multiply it, you get 96. C to the 4th comes out as c squared, and d to the 8th comes out as d to the 4th. And how many got it? Good. How do you feel with multiplication? Good? Outside with outside, inside with inside, and then you simplify. All right, so let's go to, yes, I can go back. That's all right. Let's go to addition and subtraction. Tell me about what you know normally when we add and subtract. What do you know has to happen before you add and subtract? I hear common denominators. I hear things need to match in order for you to add and subtract them. Well, it is no different, okay? In order to add and subtract a radical, the radical needs to match. So, do our radicals match? No. So we can't add and subtract them as is. So what do you think we could do with the square root of 98? We could try to simplify it. Yeah, so go ahead and simplify the square root of 98 and the square root of 32 and see then if your radicals match. All right, so when we break down 98, we get 49 and 2, and we break down 49, so we can circle a group of 7s, and so we have 7 times the square root of 2. Any questions about that? When we break down 32, we can break that down into 8 and 4, and 2 and 2, and 4 and 2, and 2 and 2. So how many pairs of 2's can I? 1, 2 pairs, right? And when I take 2 pairs of 2's out, that's going to make how much on the outside? 4, but you got to multiply it with this 2, so that will make -8 on the outside. And then you've got this little baby on the inside still. So now, do our radicals match? Yes. So let me ask you this. When you normally add, let's just say fractions, 1/8 plus 2/8 gives you what? So notice the part that is common does what? Stays the same. Same thing here. The radical that is common is going to stay the same. So you just subtract what's on the outside. So 7 times the square root of 2 minus 8 times the square root of 2 is -1 times the square root of 2. Any questions on, in order to add and subtract, they must be like radicals. Okay. So you try this one on your own. everybody okay with 23 times the square root of 2? Do anybody want to see it? Okay, really quickly. If I take the 8 and break it down into 4 and 2, and 2 and 2, I can circle a group of 2's. So I've got the 4 on the outside. I've also got a 2 on the outside, and I've got this 2 left on the inside. So that's going to make 8 times the square root of 2. So far, so good? Okay. When I take 50 and break it down into 25 and 2, and then a pair of 5's. So I've got a 5 on the outside. And I've also got this 3 on the outside, and then I've got the 2 left on the inside. So when I times the 5 and the 3, that's going to make 15 times the square root of 2. And then you just add them together, okay? Does that help out a little bit? Right. One more adding and subtracting, and then we're going to move to the last part for today. How do you add and subtract 3 terms together? You do the first 2 first, get an answer, and then try to combine it with the third part. If I were you, I would take all of them and simplify all of them to begin with. When I simplify each piece, what do I get when I simplify 5 times the square root of 12? 10 times the square root of 3. Okay, what do I get when I simplify 2 times the square root of 27? 6 times the square root of 3. Okay, what do I get when I simplify the square root of 128? 8 times the square root of 2. Yeah, and everybody's kind of iffy on that. Why are you iffy on that? Because it don't match. And I just told you that sometimes you will have some that match, and sometimes you have some that don't match. You can only add the ones together that match. So which ones match? You can combine these and make what? 16 times the square root of 3. What do you do with this? Just bring it down, and there's your answer. You just have to leave it as is. So the answer is 16 times the square root of 3 minus 8 times the square root of 2. Now, if it did match, you could go ahead and keep going and get your final answer. But if they don't match, you just have to leave them. Any questions on adding and subtracting? So we have multiplied today. We have divided today and learned how to rationalize single radicals. We have added and subtracted today. Let's look at one more concept. Everything that we have looked at so far has been single radicals, right? What are we looking at now? More than one, specifically, what would we call it? Yeah, these are polynomials, okay? A binomial times a binomial. Everybody agree? A binomial times a binomial. And it's asking us to multiply. So what word are we thinking? FOIL. And that's what we're going to do. Okay, we're just going to FOIL this together and see what we get up. So first times first. 4 times the square root of 3 times 3 times the square root of 2. What do you think? 12 times the square root of 6. Remember, outside with outside and inside with inside. Okay? 4 times the square root of 3 times negative 6. Negative 24 times the square root of 3. Holler if I lose you. Be very careful. Insides, 5 times the square root of 2 times 3 times the square root of 2. Technically, it's 15 times the square root of 4. You got to do inside times inside. But what is the square root of 4? So, so what will I write here? I'll write 30. Okay, so I'm going to take it piece by piece. Outside with outside, you'll have a 15. Inside times inside, you'll have the square root of 4. Okay? And then I'm going to keep going in a minute. Last times last, what will I have? Negative 30 times the square root of 2. Okay? Now, is there any part up there that I can simplify? The square root of 4 can come out as a 2. Okay, so 12 times the square root of 6 does not simplify. If you could, you would, but we can't, so we won't. Okay, this guy right here can't simplify either. When I take the 4 out, this becomes plus 30. What kind of radical do I have? You don't have one, right? Because we took it to the outside. And this guy right here cannot simplify either. So you check them. If they can simplify, if they can break down, you need to simplify them further. Then you have to look at them and say, okay, it's asking us to add and subtract like terms now, but are any of them like terms? Could you cancel out the 30s? Why not? One has a square root of 2 attached to it, one doesn't. They don't match, okay? So I will say at this point in time you are finished. Okay? You just FOIL it out and you are finished. All right, 2 more examples. Is this a binomial times a binomial? Yes. So we're going to FOIL it. So I'll give you a second. Go ahead and FOIL it for me. Okay, who's got an answer? Taylor. 12 times the square root of 15 plus 24 times the square root of 6 minus 10 times the square root of 5 minus 20 times the square root of 2. Can anything simplify? Does anything match? So you are finished. Okay. Really quickly before we move on to our last example, just want to give you a heads up for your homework. Would you be okay, because we have discussed this before, would you be okay, what if I had 6 times the square root of 3 minus 5 squared? Would you know what to do with that? Does that mean the 2 goes to this and the 2 goes to that? No. If you square something, you multiply it by itself. So we would set it up 6 times the square root of 3 minus 5 times 6 times the square root of 3 minus 5. And then you would FOIL it. Okay? So if it has a square with it, you can't just take the square to everything. You've got to write it out twice and FOIL it. Does everybody understand that? Okay? All right, last one. So could you write that one, just quantity squared? Is that the same thing times the same thing? Why? The signs are different, right? Anybody recognize what this is? It's a difference of 2 squares. Yeah. Check it out. See what you get. Go ahead and multiply it out, though. Who's got the magic answer? What's Emily think? Huh? Got 1? Okay. Other thoughts? I hear 71. No, never, never. I love the thoughts. Did you have anything that canceled? Or at least in the ballpark? Did certain things start to cancel? All right, let's check this out. Here we go. And I appreciate you being willing to offer me answers. That's how we learn. So, Emily, this one's for you. 7 times the square root of 2 times 7 times the square root of 2. 7 times 7 is 49. And square root of 2 times square root of 2 is the square root of 4, right? Outsides is going to give me 21 times the square root of 6. Insides is going to give me negative 21 times the square root of 6. Now it's starting to look like a difference of 2 squares, kind of. Okay? Negative 3 times square root of 3 times 3 times square root of 3. Negative 3 times 3, outside times outside, is negative 9. And then square root of 3 times square root of 3 technically is square root of 9, right? So let's start simplifying what we can simplify. Okay? What do you know about the middles? They cancel, like normal, like a difference of 2 squares. Okay? Can you simplify 49 times the square root of 4? Square root of 4 can come to the outside as a 2. So what will we have here? 98. Okay, those canceled. Square root of 9 can come to the outside as a 3. So minus 27. And then you can put them together because they're just integers. 71. Sure, great question. So as we get, tomorrow we're going to be foiling a lot because we've talked about how to rationalize single radicals, but we're going to be rationalizing tomorrow binomials by multiplying by the conjugate, which is going to end up being a difference of 2 squares, and the outer and the inner will cancel. So when you realize that it is a difference of 2 squares, you realize that this and this will cancel. You don't have to do this part. So as we get going, but I don't want you to just think on any binomial like this one that you can just do first and last and be done, because you got to do first, outer, inner, last. You got to do all the pieces and parts. But if you can recognize that it is a difference of 2 squares, you know that the outer and the inner cancel. We won't have to do all that. Okay? All right. Any questions?